Assalamualaikum warahmatullahi wabarakatuh. My name is Nurmazata Kibria binti Abdul Maulud. My mature number is AA20153. I want to present my part, which is introduction. For our group project, we have decided to do some improvement at the fire alarm system. We have added some of additional components such as LCD, LED, and also buzzer. Our project is used to read and state the condition of the temperature by displaying at LED and by show the LED color, whether it is hot, very hot, cold, in the minus cold state. Our objective of this project is firstly is to reduce the death rate in the event of the fire cases. Secondly, as a precautionary system before the occurrence of an accident to warn others, we are using the buzzer as an alarm for our system, and the buzzer is used to alert others when the emergency occurs. Lastly, to identify and read the temperature and conditions in our surrounding. By that, we can get the early notifications before the emergency occurs, so we can do something to prevent it. As we realize, in our country, we usually have a fire cases, whether it is a big cases or a small cases. From that, it can cause death, injury, and also damage the properties. The main or the biggest factor of this accident is because of the person's negligence and the high temperature of surrounding. Therefore, we choose to do the smart fire alarm to keep the safety of our user. This is an example of my research about our project because it is also related to the fire alarm system. That's all from me. Thank you.
Assalamualaikum and hi, my name is Nabiha binti Zubatuhan. My matric number is AA201028. Today, I will present about project operation explanation. A fire alarm or a smart alarm is a subject of our project. These devices are used in crowded and potentially combustible places, including school, lab, hospitals, shopping malls, and workplace. There is no temperature sensitive sensor in the temperature sensor TMP36. Instead, this sensor employs a diode which changes voltage to a predetermined pace when the temperature of the diode varies. Small changes are converted into an analog voltage range from 0 to 1.75 voltage DC by the sensor. When the sensor detects heat or a smoke, it emits a siren like a sound buzzer to alert others. User will also notify the current ambient temperature if it is safe or dangerous. When the temperature rises to degree where it is hot, extremely hot or chilly, the temperature reading will be shown on the LCD and through the LED light when the temperature exceeds a level of hot, extremely hot, cool, very cool or negative degrees. As a result, when the LED flashes, the user can figure out what's wrong and take action before the things become worse. Next, I will present about the list of components. First, we have a Arduino Uno R3. It is an 80 328p based microcontroller. The operation voltage of the Arduino is 5 volts. The recommended input voltage range from 7 volts to 12 volts. The input voltage limit is 6 volts to 20 volts. Next, we have temperature sensor TMP36. The power supply is between 2.7 volts until 5.5 volts. The current consumption is 5 microampere. The temperature range is negative 14 degrees Celsius to 125 degrees Celsius. The accuracy is 2 degrees Celsius. The output voltage at 25 degrees Celsius is 750 millivolts. The output voltage range is between 100 to 2000 millivolts. Next, we have LCD 16 times 2. The operation voltage of this display range from 4.7 volts to 5.3 volts. The display base is 72 times 25 mm. The operation current is 1 mm without a backlight. Then we have 250 kilo ohm potentiometer. Resistance value is 250 kilo ohms. The material is plastic and metal. The rotation angle is 300 degree. The tolerance is 20%. The mountain cup is through holes. The number of terminals is 3. Shaft diameter is 6 mm. Shaft length is 7 mm. The next component is 1 kilo ohm resistor. Resistance is 1000. The tolerance is 5%. The composition is carbon field. Size is standard. The mountain fixture is through hole. Then we have a piezo. This sensor contains as impedance value 500 ohms. This sensor generally operates in temperature range of approximately 20 degrees Celsius to 60 degrees Celsius. These sensors are to be kept in temperature between negative 30 degrees Celsius to 70 degrees Celsius to prevent them from degradation. Let's move on to the next component. We have red LED. The red LED wavelength range is between 610 until 716. The forward voltage is between 1.6 volts to 2.0 volts. The wavelength range for the yellow LED is between 570 until 519. The forward voltage for yellow LED is between 2.5 until 2.2 volts. Lastly, we have a green LED. The green LED wavelength range is between 500 until 570. The forward voltage is between 1.9 until 4.0 volts. Lastly, I will explain about the scope of project. In Malaysia, developing a sensor model suite of a 5-year duration. Then, study the model direction, study the model design and simulate in the Tinkercad to come up with an executable design. In Tinkercad, the C++ programming language was used in a common language. As a consumer efficiency as a source of alternative energy, the Arduino Uno R3 is a most important component in this project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilyazvi bin Muhammad Zaidi. My metric number is AA200243. Now I want to explain about methodology which have block diagram, flowchart and schematic diagram. Okay, firstly, I want to explain about block diagram. Block diagram is how the system working. So firstly, heat maybe in condition hot or cold. Okay, and then we have thermistor, which is temperature sensor. It will sense the heat and then give a signal to the controller, and then controller will give the signal to LCD whether it is in danger. Danger is more than 100 Celsius. If it sense in hot, very hot, cold, very cold, or minus degree below than 0 Celsius, and then give a signal to LED and buzzer, and so LED and buzzer will on. We have 3 LED which is red, yellow and green. the LED have a function with 3 function. Okay, and then I will explain about flowchart. Okay, first we start the system, temperature value, and then if temperature more than 90 Celsius, if true, LED red will on, and then buzzer sound will on with delay 300 millisecond, and LCD will display it is in danger, or if false, as if temperature more than 50 or more than 45, LED yellow will on and buzzer sound will on with delay 100 millisecond, and LCD will display if it is in very hot or hot, and if false again, as if temperature more than 18 Celsius or more than 0 Celsius or below 0 Celsius, LED game will on and buzzer does not sound, and LCD will display if it cold for more than 18, if very cold more than 0, for minus degree if below than 0. And then that's all for the system flowchart. Okay, next I will explain about schematic diagram. This is our schematic diagram. Okay, for schematic diagram, before we do simulation or create a circuit on Tinkercad, we will do firstly schematic diagram. For the simulation will run in good condition. Okay, so in schematic diagram we have buzzer, Arduino Uno, R3 for controller, will give signal to buzzer, and LED. We have 3 LED, which are green, yellow, red, connect with resistor. We have 3 resistor and another one. Okay, then we have LCD. LCD will display if it is in danger, very hot, cold, very cold, or minus degree. Okay, then we have temperature sensor. It is thermistor, and we have potentiometer. That's all for schematic diagram.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zafan Emil Bakri. So today my task is to present the simulation about this circuit. So this is my group circuit that we have designed. So based on this circuit, we have 1 input and 3 output. So the input is thermistor, while the output is buzzer, LED, and LCD. So let me take a look at to the code, our code. So this is our code that have been made. So we have 6 conditions based on temperature. So let me take a look to the result for this circuit. Let me open the serial monitor. So the serial monitor will print out temperature and the value of the temperature. So I switch on this circuit at the monitor. So the LCD will display the specific value of temperature and their condition, which is cold. So if I change, the button will on, and if you notice, color of LED will change from green to yellow. So now it's minus degree. So the LED will color green. So if I change to the higher level, max level, the condition will on the spot, and the color of red LED will change. So I change back to the minus degree. So I think for our circuit, that's all from me. But sorry, but before we change the projector, continue this present. So I want to talk about the survey market. So actually for this system, they have on the market. So they usually sell this market at 1,500 ringgit Malaysia to 3,500 for this circuit. So thank you.
Assalamualaikum, my name is Nazar binti Malajis and my matrix number is AA 2004. So as you can see on the slide, it is actually the least components and also the cost. So for our project, that is smart alarm system, the total cost for this application is 82 ringgit and 98 cents, which we use Arduino Uno, temperature sensor, TMP36, liquid crystal display, that is LCD, potentiometer, 1 kilo ohm resistor, we use 4, so the total is 2 ringgit and 68 cents. For our buzzer, it's piezo, the price is 28 ringgit 50 cents, and for the LED, we use 3 colors, that is red, yellow and also green, so the total of these 3 LED is 1 ringgit 50 cents. So we include also the breadboard small. The price is 3 ringgit per item. So for the next part, it is actually for benefits and usefulness this smart alarm system. So first, it is operates on a continuous monitoring system and provide protection 24 hours a day. So if the user not at home or the fire occur at night, they don't need to be worried too much. Furthermore, it is actually easy to get and affordable and requires low maintenance except for changing the battery, and requires maybe for some professional checkup for that system. And moreover, the placement is also flexible, where the user can just put the system wherever they want, and it can detect early warnings and sends the information to rescuers and people to take the actions before the fire getting worse. And for the last one, the benefits of this smart alarm system, it can reduce a risk of fire damage, since the damage causing of the fire requires the major budget. So furthermore, I will explain about the recommendation and also conclusion, where our system include of 4 items. That is a temperature sensor. We use this component to detect heat in the surrounding area. And for the LCD, we use 16:2. It's for display the surrounding temperature reading. For LED, with a different colors, red, yellow, green, we use for indicate the temperature. And for the buzzer, we send notification in form of siren or alarm. So our new features for this smart alarm system, there are 6 temperature stages in the system. There is danger, very hot, hot, cool, very cool, and minus degree. So you can see the range of the temperature on the slide. So based on these stages, the blinking LED is different, where the danger is red, very hot and hot is yellow, and cool, very cool, and minus degree, the blinking LED will be the green one. So our system objective is to ensuring the safety of users, and of course we improvise this system to reducing the death rate due to the fire causes, and it is actually for precautionary system before the occurrence of any accidents. So our system is very important and always ensuring the safety of the users and for other people. So this alarm system can help to reduce risk of fire damage, detect early warnings, operates on a continuous and monitoring system very well. So for the last from me, this system and application very useful for detect fire, to warning people for taking some action, and controlling risk, also notifying the fire department for the dangerous environment.